In this question, we've been presented with a Venn diagram and we've first been asked to explain whether or not events A and B are independent, and we've been asked to show our working clearly. Okay, so if two events are independent, we know that the probability of A times the probability of B will equal the intersection of the two. First, to find the probability of A, rather than reaching for my calculator, I'm just going to use equivalent fractions, and 2/5 can become 6/15. I know that the probability of A is going to be 10 over 15. In a similar way, I know that 4 over 15 plus 1 over 4 is going to give me 31 over 60. If I multiply these two fractions, do I get 4 over 15? If I do, then they're independent. Let's write this down. 10 over 15 times 31 over 60. In my calculator, I get 62 over 90. That is not equivalent to 4 over 15. So these two events are not independent. In part B, we're asked to find the probability of B given not A. So the probability that is B, if we already know it's not A. So the formula here is the intersection of the two divided by the probability of the second one. The intersection of B and not A, so inside B, outside A, well, that's 1/4. The probability that is outside of A, well, that's going to be 1/3. 1/4 divided by 1/3 gives us 3 over 4. Part C of the question wants us to go ahead and complete the tree diagram. Well, the probability of A we already found. It was 2/3 when we simplified, so the probability of not A is 1/3. Part B just asked us to find the probability of B given not A, so that's a probability we can add to the tree diagram straight away. Here we go, it's the B that follows not A, and it's 3/4. That means its complement is 1/4. Now we're left with finding these last two. What is the probability of B given that it was A? So just look into the Venn diagram again. If we know that it's A, that's the 4/15 and the 6/15. So out of those 10/15, we are specifically interested in the section in the region that contains B. So out of those 10/15, we're interested in 4 of them. 4 of those 10. 4 over 10 is the probability of B given A. 6 over 10 is its complement.